Okay, in last class we were discussing about balancing. So just we have covered introduction part about balancing, and then we were discussing problems on balancing. Okay, so we'll just continue with the problems. Yesterday, so we have discussed about balancing. Then we have discussed what is horizontal force and what is vertical force and resultant, then angle. So how these formula you are getting, that we have discussed. Okay, and then we have discussed so how to get the resultant and angle of the balanced mass we have discussed. Okay, in today's lecture we will just discuss one problem on balancing. Okay, so this is the problem, that is there are four masses m1, m2, m3 and m4. That is, those are 200 kg, 300 kg, 240 and 260 kg. So I have taken those masses. That is, first is m1 200 kg, m2 300, m3 is 240 and m4 is 260 kg. And then the radius are given, that is radius of rotation are 0.2, that is r1 is 0.2, r2 is 0.15, r3 is 0.25 and r4 is 0.3. These are the radius are given. Now what I will do is I will just multiply these two, that is m1 into r1, that is 200 into 0.2, we will get 240 kg meter. Okay, mass is in kg and the radius is in meter, so kg into meter will be kg meter, that is 40. Then I will multiply 300 into 0.15, so I will get 45 kg meter. Then I will multiply 240 into 0.25, I will get 60 kg meter. And m4 into r4, that is 260 into 0.3, you will get 78 kg meter. Then m into r. Now in this problem what we have to find is, we have to find balanced mass m, and the radius is given. Radius of balanced mass is given here. At last, radius of rotation is 0.2, that is for balanced mass it is given. So it is m into r. So m into r, same thing, whatever you are multiplying, you have to multiply m into r, you are getting okay, that is 0.2 into 0.2 is radius and m is this m, whatever you are finding m, that is 0.2 m. Okay, these are the given data. Okay, then the angles are given. Next, if you just read the question, angle of masses are 45 degree, 120 degree and 255 degree from mass 1. Okay, from mass 1 it is given. That is, always you have to take first mass as 0 degree. Always it will be, this will be 0 degree. m1 will be 0 degree. From m1, so how much first angle it is given? 45 degree. That will be theta 2. Theta 2 will be how much? 45 degree. Then theta 3 is 120 degree. It is given here. So theta 3 is 120 degree and theta 4 is how much? 255 degree. So it is 255 degree. So in diagram you can see m1 is 0 degree, then m2 is 45 degree, from m1 it is 45 degree, m3 is how much? 120 degree, that is 120 degree, and m4 is 255 degree from mass 1. From, always I have taken all these masses from m1, because in your problem statement it is given from m1. Okay, so after writing theta 1, theta 2, theta 3 and theta 4, what you have to do is, theta 1 is 0 degree, theta 2 is 40, theta 1 is always 0 degree, it is, theta 2 is 45 degree, theta 3 is 120 and theta 4 is 255 degree. So after writing these four angles, next what you have to do is, you have to find sine of these angles. That is, first one is sine of 0 degree. How you have to find is, in your calculator you have to press sine, then you have to take bracket, then you have to type that angle. That is 0 degree is the theta 1, so sine 0 you will get that value as, and then you press equal to, you will get the value. Sine 0 is 0 degree you will get. Then sin theta 2, that is sin theta 2 is how much? 45 degree. So sin of 45 degree you are getting 0.707. Sin 120 degree you have to find. Then theta 3 is sin 120 degree, you will get 0.86. Then sin theta 4, that is sin 255 degree, if you just type you will get 0.96, that is minus value you will get, keep as it is, minus 0.96. Now similarly you find for cos theta 1, that is cos of 0 degree. If you just type it in calculator you will get 1. So you just write that value. Now sin cos of 45 degree you find out, that you will get 0.707. Then cos of 120 degree you will get minus 0.50. So, cos of next is 255 degree, you are getting minus 0.25. And these are what? M1 R1 you are getting 40, 45, 60 and 78 and 0.2. From where you are getting? These you are getting from here. These values only I have written again here, so that you will get. And then this diagram you need to draw. A rough diagram you can draw. You can take angles also, 45 degree. Then roughly you can just draw a line and just mark this as M1, okay, M2, okay, M3 and M4, you can just mark. So this is the first procedure. Whenever you are getting a problem, you have to write M1, first M1 you have to masses you have to write, then you have to write radius you have to write, then you have to multiply those, then you have to write the angles, then you have to find the sin theta, then cos theta, and then M1 R1 you have to write. Okay, so I hope you have understood this. We will just proceed with the next procedure. Okay, next procedure, okay, next procedure is very simple. Next is you have to just write the formula and go on substituting. So now what is horizontal component? You know that horizontal force is given by delta H is equal to M1 R1 cos theta 1, M2 R2 cos theta 2, M3 R3 cos theta 3. Okay, this whole okay, you know the cos theta, in terms of cos, whole formula will be coming. Now what you have to do? Now M1 R1 is what? Now you have found out M1 R1 is how much? 40. So you just substitute here 40 into, okay, into what is cos theta 1? Cos theta 1 is what? Here you are getting cos theta 1 is 1. So you just substitute that. Okay, cos theta 1 is 1 into 1. Next is M2 R2. What is M2 R2? M2 R2 is 45 into cos theta 2. Into cos theta 2 is 0.707. That is M2 R2 is 45 into 0.707. Next M3 R3 is how much? M3 R3 is 60 into minus 0.50. So you just substitute 60 into minus 0.50, that is minus, you have to take it in bracket. Next M4 R4 is what? M4 R4 is 78 into minus 25, minus 0.25. So that is 78 into minus 0.25. Now 40 into 1 you will get 40. 45 into 0.707 you will get 31.81. 60 into minus 0.5 you will get minus 30. 78 into minus 0.25 you will get minus 19.5. You have to consider the sign also. If it is positive you have to take plus, if it is negative you have to take negative term. So after adding all this you are getting how much? Delta H is equal to 22.31 kg meter. Why kg meter? Because M1 R1 is in kg meter and theta is cos theta is nothing but it is value, so we will not get any units for that. See, we have found out horizontal component as 22.31. now you have to find vertical force. For vertical force, what formula you are using? Same formula you are using, because instead of cos theta you have to use sin theta. M1 R1 sin theta 1, M2 R2 sin theta 2, M3 R3 sin theta 3, M4 R4 sin theta 4. Now you just go on, okay, adding the values. That is M1 R1 is how much? M1 is 40 is there. 40 into, now you have to multiply these values. So that is 40 into 0. So 40 into 0. So 40 into 0. Next is M2 is how much? M2 R2 is 45 is there. So now 45 into 0.707. So 45 into 0.707. Next 60 into 0.86. Now multiply 60 into 0.86. Then last is 78 into M4R4, that is 78 is there. So 78 into 0.96. So when you multiply all these and add, you will get 8.53. So now you are getting horizontal forces, okay, horizontal 22.31 and vertical you are getting 8.53. So now next procedure is what? Just use these formulas, two formulas, that is resultant is equal to is given by square root of delta h square plus delta v square, horizontal square plus vertical. Horizontal how much you are getting? You are getting 22.31, okay, square plus 8.53. what is it? 22 is here, okay, 8.53 is here, okay. So 22.31 square plus 8.53 square. So now square root you remain as it is, okay. Now you are getting 22.31 square as 497. 8.53 square if you just do 72.76 you are getting. You add both 497 plus 72, you will get 570. Okay, now you take square root of, you just type square root of, okay, 570.46, you are getting 23.88. So you are getting 23.88. Now resultant is what? Resultant is nothing but m into r. Resultant is also a force, it is balanced force. So resultant will be m into r. M value you have to find. So now r is given. So r is how much it is given here. So just see here, it is r is given as, okay, 0.2. Here we are done. No? See here, last step, m into r is 0.2 m. So m into r, you just substitute 0.2 m. So now 0.2 m is equal to 23.88 you are getting. Now if you want mass m, okay, then 0.2 you send it this side. When it becomes this side, it goes down. Okay, now m becomes, okay, that is 23.8 divided by 0.2. okay, if you just divide this, you will get the answer as balanced mass is equal to 119.4 kg. So balanced mass you are finding. So instead of taking all those masses, you can balance those all four masses by one mass, that is equal to 119.4 kg, or it is around 120 kg. Now you have found out that is what is the mass. Now we will find angle. For finding angle, what you are taking, theta is equal to tan inverse of delta v, that is vertical component, divided by delta h, that is horizontal component. Delta v is how much here? If you just see, delta v is 8.53, delta h is 22.31. So you just divide 8.53 delta v, okay, and then delta h is 22.31 delta h. If you just divide, you tan inverse you just keep as it is, tan inverse. So if you just divide, you will get 0.382 you are getting. So now 8.53 divided by 22.31, you are getting 0.382. Now how to take a tan inverse? See, you can easily take tan by just pressing tan and value, okay. But how to take tan inverse is, just in your calculator you press shift, then you press tan, you will get tan inverse, okay, of this value you will get 20 degree. That means, see, if you are taking, you are having four masses, okay, you are having four masses, that is like this. If you are having, so m1, okay, m2, m3, okay, and m4, you are having four masses. See, you can balance all these four masses by only one mass m, which is at angle 20 degree. So that is 20 degree, where you are getting in your problem, you are getting 20 degree, and that mass value is how much? It is 119.4 kg. So m will be around 1 19 kg, 0.4 kg, okay, kg, and theta will be how much? It will be 120.8 degree. Okay, so what we are doing here is we are finding what is the mass, balanced mass and balanced angle in this problem. I hope you have understood all this whole procedure. So you just sit with your okay notes and just note down all these things, and just try to just okay rewind the video and try to operate the calculator on your own and try to solve the problem. If you are having any doubts, you can come up and you can just clarify those. Okay, see, this is a simple procedure. Whatever we have solved today, same type of problems will be asked in exam for 10 marks. Okay, it is fixed problem, on fixed problem will be asked. You just go through this procedure. If you understand one problem, all the problems are similar to all other problems are similar to this procedure. You just try to understand this procedure. For this, what you have to do is you have to remember these four formulas, that is delta H, horizontal force, vertical force, then resultant, then angle. If you remember these four formulas, easily you can solve any type of problem. So you just try to practice this, okay, this question, and just try to operate the calculator and just try to solve the problem. Okay, okay, so in this lecture we are covering this one simple problem. So from tomorrow onwards we will just take another one or two problems in each lecture. Okay, and just try to solve these problems. Okay, thank you.